Hi again, folks. Tom McNamara back, looking at some more My Math Lab problems dealing with quadratic functions. In this question, we have been given the graph of a quadratic function, and we are challenged to find the formula for that quadratic function. Okay, so we can see this U shape here. So we are thinking it's a quadratic function because all quadratic functions have that U-shaped graph called a parabola. And I'm especially interested in the vertex of this quadratic function. Okay, so I'm looking here where the function turns around, and it looks like the x-coordinate of that point is 1, 2, 3 units to the left. So the x-coordinate is -3, and I've gone 1, 2, 3, 4 units down. So the vertex of my quadratic function is -3, 4. So I can start writing my function right here. It would be, and let me go ahead and zoom in. Zoomed in a little too much there. I'll zoom in a little bit so we can make it bigger, see it hopefully a bit better. So I'm thinking about how transformations work with my functions, and I know if I want to move to the left, I need to replace x with x plus something. So instead of x squared, I should do x plus 3 quantity squared. Okay, there's a couple ways you can do that. You can get the exponent by clicking this button, or I just hit the caret, shift 6, and it'll get you into the exponent. Okay, so instead of x squared, I do x plus 3 squared. That will shift the graph 3 left. I wanted to go 4 down. So I put a -4 on the outside of the squaring function, and that'll do the job. Now, one other thing to notice, the only other question is what's the value of a? Well, my graph opens up, so I know that a should be positive. And I want you to look back to the video that we did about graphing quadratic functions in vertex form. Notice the standard jumps were over 1, up 1, over 1, up 3, over 1, up 5, and look what we got going here. Over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, 2, 3, 4, and 5. Okay, so this graph is matching the standard jumps, so there is no vertical stretching. The fact that it opens up tells me that a should be positive, and the fact that the jumps match the jumps in the graph of y equals x squared tells me the lead coefficient should be 1, so I actually don't really need to put it in there. I don't think it would count it wrong if I did. Okay, so I just left it blank. Okay, now let's look at this one. Okay, once again, we're given the graph, and we are challenged to come up with the vertex formula for this graph. So let's look at where our vertex is. 1 unit left, 3 units up. So that means I'm dealing with this, okay? X plus 1 quantity squared plus 3. That would be a shift, 1 unit left, 3 units up. Now notice this graph opens down, so my lead coefficient should be negative, all right? But there's more to it. Notice, if my lead coefficient were just -1, as I've got right here, it would be over 1, down 1. But that's not happening. I'm going over 1, down 1, 2, 3, 4, 5. Over 1, down 5. That tells me this lead coefficient should be -5. Negative because it's going down, and 5 because that's the jump from the vertex to the next point on the graph that's on the grid. Okay, so let me check my answer here. I bet I got it right. Okay, wonderful. Okay, so a couple of things. If I give you the formula for a quadratic function, I expect you to be able to draw the graph of that quadratic function. And I'm also expecting you to go the other way. You can take information about the graph and write down the function's formula, especially this vertex form of the formula. Especially easy, okay? So be prepared to deal with questions that go either direction.